Hello, this video is for Notes 8.2 and Homework 8.2, Dividing Polynomials. Dividing polynomials is also known as factoring. And in fact, that's what most people will say is factoring polynomials. So when we divide a polynomial by a monomial, then we do this by turning it into a fraction. So for example, if we're given this problem, then we're going to express this as a large fraction, and we'll put the divisor underneath of the fraction bar. And then what we can do is you can split this into three individual fractions where each term of the trinomial numerator is its own fraction over the monomial denominator. So we get 2x to the fourth over 10x squared plus 30x cubed over 10x squared plus 2x squared over 10x squared. Then we'll use our exponent rules to simplify this further. So for example, in this first fraction, 2 over 10 will reduce to 1/5. That's why my answer starts with 1/5. Now there is a 1 in front of the x squared, but you don't have to write it. Using the quotient rule for exponents, x to the fourth over x squared becomes x squared. For the second fraction, 30 divided by 10 is 3. So I know that it starts out with a 3. X cubed over x squared, well, what happens is both of these x's are going to go away with 2 of the 3 x's in the numerator, leaving me with 1x in the numerator. The third fraction is another 2 over 10, so that becomes 1/5. And then x squared over x squared we can just cross out because it equals 1. And that is our answer. Try another one of these. So this time we're dividing by 9v cubed, so we'll set up our fraction. Now you don't have to divide this into 3 separate fractions. You can just look at, say, this part first, do that part, then worry about this part, and so forth. So what I end up with, well, I guess I actually did write it as 3 separate fractions though. The 4 over 9, you cannot simplify, so it will remain in our answer. The v squared over v cubed, well, these two v's are going to essentially cancel out with 2 of the 3 v's in the denominator, leaving me with 1 v in the denominator. The second fraction, 3 over 9, reduces to 1/3, and v over v cubed reduces to 1 over v squared. In our third fraction, v cubed over itself is 1, and 3/9 is 1/3. Moving on. Sometimes we'll just look for a GCF. Well, you should always look for a greatest common factor, but sometimes that's all you can do. So for example, in 4x plus 12, you should notice that you can divide 4 out of both of these terms. So we put the GCF in front of parentheses. So essentially what you're doing is undistributing. You're doing the opposite of the distributive property. In this second one, there is no numerical greatest common factor. However, I do notice that there is an x in both terms. Because of that, I can extract an x from both terms. And in fact, you're going to extract the number of x's that is the lowest degreed term, meaning I can divide both of these by x to the first power, because that's going to cause this to cancel, and then one of these will cancel, but you could see I still have one left inside the parentheses. So our answer here is x times the quantity x minus 5. And again, if you were to distribute this, you will get the original polynomial. Here's a special case. You're going to see later on when we learn more about quadratics that we want our first, not first, but we want our first term to be positive. And in this case, since it's negative, we're going to get rid of that negative by factoring out a -1. So we can write this like this. Now we're asking ourselves, what number here multiplies by -1 to equal -x? So you would put x here, because -1 times x is -x. Then you're asking yourself, what number goes here that multiplies by -1 to equal -7? Well, that would have to be +7, because 7 times -1 is -7. So the solution on this one, or not solution, but the simplified form after we factor out a -1 is -1 times the quantity x plus 7. So now we've gotten rid of the negative sign on the polynomial by extracting it and putting it out front of the parentheses. Then there's another type of factoring that involves GCFs. So in this case, I notice that there is no GCF for all 4 terms. But we can be a little creative here, and we can find a GCF from these 2 terms. Then you might also notice that there's a GCF that we could extract from these 2 terms. So let's see what happens when we do that. So from the first 2 terms, I have a GCF of 2n squared, because I can divide 2n squared out of both of those terms and not get a fraction. For these 2 terms, I have a GCF of 5. So if I write this out, I'm going to get 2n squared, and then what am I left with here? Remember, we are undistributing. So in other words, 2n squared times what equals 10n cubed? Well, that would be 5n, because 2n squared times 5n is 10n cubed. 2n squared times what equals -8n squared? Well, that would just be -4, because 2n squared times -4 is -8n squared. Okay, let's clean this up a little bit. So we already did this, so we can get rid of that part. So now what we'll do is this part. Remember, my GCF is 5. So I'll put plus 5 and then my parentheses. So 5 times what is 25n? Well, that would be 5n. And then 5 times what is negative 20? That would be minus 4. So now what we want to do is make an observation here that I have two terms now. I have this term and I have this term. And now let's notice that in both of those terms, the yellow one and the green one, I have a common factor. There is a 5n minus 4 in both terms. That means it's a GCF. That means I can factor it out. So what this will look like is this is going to come out front and this is going to come out front. And I will be left with the following. So I'm going to factor out the 5n minus 4 and multiply it by everything left, which is 2n squared plus 5. And that's my answer. Now, you could test this out yourself, but if you FOIL this, multiply those two binomials, you will get the original polynomial. All right, let's try another one like this, but it's from the homework assignment. So this is number 12 on the assignment. So again, we're going to try to find, like, first of all, see if there's a GCF for the entire thing. And there's not. The problem is these terms are divisible by 2, but that one's not. Another thing we could do is maybe factor out an x. These 3 are divisible by x, but that one's not. So we have to look for a GCF of this part and a GCF of that part. And by the way, this has a name. It's called factoring by grouping, because you're grouping the larger polynomial into 2 smaller parts. Okay, so we're looking for a GCF of this part, and it's x squared. Then we want a GCF over here. Now, remember, we don't want to start a polynomial with a negative. And since I have this minus sign in the middle here, I want to factor that out. So my GCF here is going to be negative 2. All right, so let's write our polynomial, or rewrite it, with these GCFs factored out. So we'll put x squared times some stuff, and then we're going to put minus 2 times some stuff. Okay, so x squared times what equals 3x cubed? That would be 3x. X squared times what equals 2x squared? That would be 2. Here's where it can be slightly tricky. So let me erase all this mess here so we can see it more clearly. Remember what we're factoring out here. We're factoring out a -2. So you're saying -2 times what equals this? Well, -2 times 3x equals -6x. Now we need to know -2 times what equals -4. And that is +2. And you can check all of this just by multiplying it out. So this part here, if you distribute that, you will get this, -6x -4. All right, our last step. Our last step is to factor out this common factor. So that gives us, when we extract this GCF, we're going to get 3x plus 2 times everything that was left up here, x squared minus 2. And if you take these two binomials and multiply them together, you will indeed get the original polynomial. All right, so if you have any questions about this, join our Algebra 1 Math Help meeting on Tuesday. You can send me a message on Remind at any time, and I'll get back to you as soon as I get the message. Until next time, take care of yourselves, stay healthy. Thank you.